Hi to another TMS WEB Core video. Today we're going to continue an example that we started. We're going to look at how to place map data that is based on databases on a Google map. Just a brief remark for the following videos. You see these two students jumping in joy. I'm going to use this icon to indicate that all the following videos that carry this icon belong to the same set of videos. So what we did so far is we used a hands-on example with real data that is easily reproducible, and we already built the XData server. You can find the video on the link that is given on the slide. And in this video, you learn about the database, about the data that's being shown, and you also learn how to create the connection between a web application and the XData server that connects us to the database. We also motivated why we need XData in this place and why it makes development so easy. Just as a brief repetition of the data that is stored in the database, we have a list of all the schools in Lee County, Florida. And also in this data set are the coordinates where all these schools are. So it's kind of nice to display not only a list of the schools like we did in the first video. No, we're actually going to visualize where these schools are. So without further ado, let me show you a screenshot from the application that we're going to develop in this video. You see here it's clearly a web application as it's running in the browser, Chrome in this case. And we simply place the map on the whole screen. The whole web browser is being used for the application. And here you see tiny little houses indicating the location of the schools. And they're all located around Fort Myers, of course, because it's Lee County, Florida. Furthermore, you have the full functionality of the Google Maps API. And let me rephrase this again, that this component is part of TMS WEB Core. That means you don't need to purchase any additional components. This is part of the basic package, so to speak. If you own TMS WEB Core, you own this component. The only thing you need to do is you need to get in touch with Google and get a Google API key so you can use this Google Map component. But that's very detailed, described in the documentation. I'm not going to lose any time on that. Instead, we're going to focus how to develop this application that has not so much of a visual vibe because it's just the map. In the next video after this one, we are going to look at design, and we're going to design using Bootstrap and Photoshop and all that kind of stuff. I'm going to show you how it's possible that you work in conjunction with your web designer. And you see here the map is part of the design. So we can focus on building the map, and the map at a later stage is being included in a design that's being created by a professional web designer if you want. Still, I'm going to show you how you can build web design using Bootstrap with hands-on material, even though you're not a web developer. And this already looks better than simply having a web browser and the map. So in this video, I'm going to look at the database table again real quick. Then we're going to look how the result from the XData server looks like, so you get a feeling how these things interact with each other. And then we're going to jump right into Delphi and develop the TMS web application using the application creation wizard. And we are going to access the XData server again, as we learned in the previous example. Practice makes perfect, you know. And finally, we're going to write the code that adds the markers onto the map according to the data that we have in the data set. And this is something new. We're actually going to access the data set. We're going to iterate through all the records. We're going to use tfield object instances. And this is very much the same approach as you would use in the VCL. However, there's a slight difference because you can't rely on the fact that if you open your data set, in the next line of your code, the data set is actually open, because in the web, everything is asynchronous. So you have to hook up all the different actions in the application to different events that are triggered. So that's what I'm going to show you, how to do that, what the triggers are, and how you have to approach these things. It takes some time getting used to the asynchronous nature of TMS Web, but that's the web, because in the end, you're going to get a JavaScript application that runs in the web. So you can't rely on the same concepts that you're used to from Delphi or the VCL. So this is something you can't circumvent, but using the events from components makes it very easy, and it's not nearly as complicated as building a multi-threaded application in the VCL. This form here, and this is the basis of all the demo work that we're going to do now, is the XData server that we built in the last video. I pimped it up visually, and there will be arguments about why did you pimp it up visually? Nobody's going to see it. It's going to run on a server. I disagree. I like servers that have some kind of graphical user interface. As you can see here, the log, we're going to focus on that at a later stage because logging has just become part of XData, so you can log everything that goes on in your server. And if you have a graphical user interface, it just makes it simpler to access. It's just as simple as that. And putting some fancy graphics in just to visualize how flexible this is. You're not restricted to anything. So here the server is already started, and I can stop it, and I get a visual representation that it stopped, and I can start it again, and we get the green check mark that it's running again. So let me look at the database that this connects to. Again, as the data is in Microsoft SQL Server, I'm going to use the Microsoft SQL Management Console. I select all the records of the school table with select star. And what we're going to focus on is, you see, we have all these different attributes that we don't really need. We have the address here, but this is something very nice that this data set offers. We also have X and Y, which is the coordinate, the latitude and the longitude. So what we're going to do in our example is we're basically going to select only the name and the coordinates. Let me show this to you. Hopefully this is easily possible, like this. This should be a valid SQL. So this is the data set that we're going to use. We have the name of the school, we have X and we have Y, and we're going to iterate these records. We start with the first, and then we're going to iterate them. As already explained in the first video, we can't connect to the database directly. This is where this little fellow comes in. You can see I also create a custom icon, and this database, XData database server, so to speak, it's an XData server. It doesn't have to be tied to a database, which I showed in another video, where you just build service operations and are totally loosely coupled from any database. There's no database in the mix, but it makes it easy to access databases. So looking at this URL, we paste the URL, and here we have our server with the dataset schools. And now we can, for example, say schools. And here you see that we also have the name of the school, we have X, and we have Y. So what we need to remember is this address, the localhost flicks. This is where the server is running. And from there we can build our application. So as we learned in the last video of this series, we can create a new TMS web application, and we switch to the form designer, and we drop a couple of visual components. What I always do is I type XData because I have, at my age, remembering what the components are called. So first we need the XData web connection to connect to the server. And if I type it correctly, we need the XData web dataset. With these two components, I'm already done with my connection to the XData server. So I'm going to rename the connection to connection, and I'm going to rename the web dataset to DS schools, because this is going to connect to the schools table, and the connection set to connection, and the entity set name is schools, which should be auto-completed. And again, I can say, oh, I messed up on purpose. Actually, in this case, I didn't. Still, it gives me the opportunity to explain this to you. The URL property is not specified. That is why I don't have any auto-completion here. So I go back to the connection and I specify the URL. I should be able to paste this. So you see localhost port 80, Flex, that's where the service is running. And if I now go back to the web dataset, entity set name schools, I press enter, and that's it. Now we have access to all the information in the schools table. And just to rephrase this, or just to repeat this, because it is a common misunderstanding, this is really direct access to the database. So there's nothing like the X-Data server pulls data from the database and the X-Data server contains some kind of data that has been extracted when you created it or whatever. No, this is a bridge. So the X-Data server really connects using a database connection to the database, and it bridges everything between the web application and the database using a format that can be used by any device or any machine on this planet. So if you were to offer your service to any other institution, that institution would be able to use this service even though they're not using X-Data, they're not using any Delphi components. They would be able to consume the JSON data without having any of these components. These components just give you, as a Delphi developer, the opportunity to save a lot of time by using the components. So I hope that cleared up that a little bit. So we have these two components. What do I need to do? I can right click this and get into the fields editor, and I should be able to add fields. Here you see it's being extracted, all the fields from the dataset. And as we elaborated before in the SQL management console, I only need the name, X, and Y. These are the three fields I'm going to focus on. I don't need anything else. So we also see, like, in the source code, we get these fields: DS schools name, DS schools X and Y. And of course, we can go back to the fields editor here, and in the object inspector, let me make this a little bit bigger. I have a tfloat field for the X value, which is this one. The Y is also a float field, which is correct, and name should be a string field. Perfect. And you can also set things like display width, display label, if you were to use graphical user interface components with the web core components that are available, like the grid, for example. So, and of course, just to finish this off, there's also X-Data components for the VCL. So you also have the ability to create the design time experience for that. Making changes to the fields, just you're used to from normal VCL applications. So going forward, what's missing? Of course, the map is missing. So we need to add the map, TWeb Google Maps and TMS Web. So this is our mapping component. I'm going to align it as AL client. That's it. And now the most important thing, apart from setting the name to, what did I name it? Maps. And here we go, API key. This is where you insert your key that you get from Google. I'm going to do this without actually showing you. So I am going to add this key, but I'm not going to show you, so I don't have to blur anything. I'm going to insert it when you're not seeing it. So we're done building the design time experience. Now everything else is going to be code. Let us start with adding the markers to the map. For that, we need to write a method, and this is a downside of the current template. We don't have like private, public areas predefined, so we need to do that all the time. And what we need to do is we design a procedure or implement a procedure called add markers. And this procedure is pretty straightforward if you read the documentation of the Google Maps component. So first of all, maps, which is a component, we need to clear any markers that are already there. This is just making sure if you call this a second time. And then we need to center our map, because if you add the markers and, for example, you're located in Australia, that doesn't help you at all, because your map is going to be focused on Australia and all your markers are going to be in Florida in the United States. So you have to move your map. That's a horrible user experience. So we are going to position the map, hard code it here using the coordinates of the center of Fort Myers, Florida. 1, 2, 3, 4, 5. It should be fine. And then we're also going to set the zoom because it should be visible. The map markers should be visible. And I'm going to set it to 12 or 13. Let's see what's better on this resolution. So we're going to assume that the data set is already open and the records have been retrieved. So what we're going to do now, we're going to iterate through all the records in the data set. And for every record in the data set, we're going to add a marker to the map. So the first thing we do is we set the position of our data set to the first record. And then we are going to iterate until we're at the end. So DS schools, EOF, do, begin. What are we going to do? We're going to add a marker. So maps add marker. And here we have several overloads. And the one I'm going to use is, at first it's going to take the latitude. That means DS schools Y. It's the field name as float. Perfect. And then we can use DS schools X as float. And now I chose to select a symbol. So we're going to use MS home, which is the little house. It's a standard symbol in the Google API, and TMS supports that. And then we are going to CL sky blue. That's the color for the house. This is a Delphi color. It's a color constant. And how do we want to name this? DS schools name as string. So we want to give it a label as well. So that's the label for the marker. Of course, there's simpler variants. For example, you can simply specify the latitude, the longitude, and the title. But I chose the one that is latitude, longitude, the shape, which is the house, and the color, and the label. So this is one of the longer ones. In order to do this, you have to maybe add certain units. Let's see if it compiles or if we need to add a unit. No, it compiles just fine. So no units need to be added. See, I'm playing fair here. I'm not doing anything behind your back. Finishing this implementation. So that's basically all we need to do, add the markers to the map. So what remains? We need to open the connection to the database. And as soon as the connection has been established, we need to retrieve the records into the data set. And that is all done using events. And it can't be done right after another. So normally in the VCL, you would write something like this, like my connection.open, and then you would say like my data set records load, my dataset.load or something like that. The problem is that this line to open the connection takes a certain amount of time that was undetermined. We don't know how long it takes. However, the execution of your application goes on to the next line right away. So this actually goes to the load as soon as the line has been executed, but the database connection hasn't been established by that time. So that's going to fail because of the asynchronous nature of the web. So what we need to do in this case is we have to find triggers how to start. So a very good trigger is if you look at the map, for example, the map has the map loaded property. So as soon as the map is loaded, we can start establishing the connection to the database. So this is when we say connection.connected equals true. This is how we establish the connection. And as soon as that is done, we need a trigger like what happens when the connection has been established. So we go to connection, and here you see on connect. So as soon as we have a connection, what is supposed to happen then? Then we can load the records into our data set. So we call ds schools.load. This is when we can load all the records into our data set. And even that is an asynchronous process. So we can't say ds schools load, ds schools first. We can't do this. We can't call at markers at this place because the load takes a certain amount of time to retrieve the records. But ds schools has an event for this, And this we find in the events, which is called after open. And after open, if that happened, we called add markers. So let me repeat this. When the map is loaded, that means when the Google API has provided us with the mapping data, then we open the database connection. When the database connection has connected, we tell the data set to load. In order to load the data, it's going to take a time, but after the data has been loaded, the data set is being opened. And there is an event called after open that we can use to then iterate through the data, which is being done in add markers, the method that we implemented first. So let's see what happens if we run this. If we run this, we find out that nothing really is showing up, and the wheel keeps turning and turning and turning, and nothing's really happening. So how did we screw up? And it's rather embarrassing, because here, look at this. Why not EOF? This is the most common mistake that I tend to make, that every database developer that develops with Delphi makes. We forgot to call dsschools next. This call moved the database cursor or the dataset cursor to the next record. So if you forget that, and I wanted to show you that, you run into an endless loop just like in the VCL or any other Delphi application, but the impact is much more visible because nothing's happening. So if you run this now, the map shows, and the map shows all the schools. And the best thing, if you point on one of the houses, it tells you which school it is. And here we go, Edgewood Academy, my wife's school, right there. So this is how easy it is to place elements on a web. And you saw the performance is rather amazing. You can switch to satellite. The markers are going to stay. You can go back to map. Basically, this is the full mapping API. You can even, I think in the United States, you can even do Street View. Yes, you can. Perfect. So you see everything like that is supported by the API. Nothing is restricted. This is the full Google Maps API at your mercy from Delphi. So I would say the only downside to this application now is that its design. So I suggest, or I'd like to invite you to watch the next video in this series where I'm going to show you how to build a proper design for such a wonderful application. So see you again soon.